Network access control functions as a comprehensive computer security approach that aims to merge various technologies like antivirus, host intrusion prevention, and vulnerability assessment, along with user or system authentication and network security enforcement. NAC is essentially a networking solution utilizing a series of protocols to establish and implement policies governing the secure access to network nodes by devices when they first attempt to connect to the network. An essential aspect of NAC involves potential integration of an automatic remediation process within network systems to rectify non-compliant nodes prior to granting access, ensuring the secure operation of the information system before permitting interoperability. A fundamental form of NAC exists in the form of the 802.x standard, which operates to control network access through policies encompassing pre-admission endpoint security checks and post-admission controls dictating user and device movement within the network and their authorized actions. For instance, upon a computer linking to a network, it must adhere to specific business policies concerning antivirus protection, system updates, and configuration. During a preliminary inspection by a pre-installed software agent, the computer's access remains limited to resources equipped to rectify any identified issues. Once the stipulated policy requirements are satisfied, the computer gains access to network resources and the Internet, abiding by the NAC system's defined policies. Predominantly, NAC is utilized for endpoint health assessments, often correlated with role-based access, where network access is granted based on the individual's profile and the outcome of a posture or health assessment. In a corporate environment, for instance, access might be restricted so that the HR department can solely reach HR department files, provided that both the designated role and the endpoint fulfill the minimum antivirus requirements. The primary objectives of network access control include the authentication, authorization, and accounting of network connections. While traditional IP networks regulate access based on IP addresses, NAC environments endeavor to enforce access policies grounded on authenticated user identities, particularly concerning user end-stations such as laptops and desktop computers. NAC solutions offer network operators the capability to define policies concerning the types of devices or user roles permitted to access specific network areas and enforce these policies within switches, routers, and various network intermediaries. Furthermore, NAC solutions provide the crucial function of verifying the security posture of connecting devices, with a key benefit being the prevention of endpoints lacking antivirus software, patches, or host intrusion prevention systems from gaining network access and potentially endangering other devices with the spread of computer infections. There are two prevailing designs in NAC: pre-admission and post-admission. In pre-admission NAC, end stations are inspected before gaining access to the network to prevent potential security risks, like out-of-date antivirus signatures from communicating with sensitive servers. On the other hand, post-admission NAC enforces policies based on user actions after granting network access. The core concept of NAC involves enabling the network to make access control decisions based on intelligence about end systems. One key divergence among NAC systems is the requirement of agent software to report end system characteristics or the utilization of scanning and network inventory techniques remotely. As NAC has evolved, major software developers such as Microsoft incorporated this idea, offering their network access protection, NAP, agent in earlier Windows releases, but discontinuing support for it starting with Windows 10. Despite this, there are still NAP-compatible agents available for Linux and Mac OS X to provide similar intelligence for those operating systems. In the realm of deployment methods, there are out-of-band and inline solutions. In out-of-band systems, agents on end stations report to a central console for policy enforcement, while inline solutions can act as internal firewalls within access layer networks, directly controlling individual packets on the wire. While out-of-band solutions reuse existing infrastructure, inline products may offer more advanced network enforcement capabilities, but there are also agentless alternatives that combine the benefits of out-of-band deployment with inline enforcement for non-compliant devices. When deploying NAC products, network operators anticipate that some legitimate clients may be denied access, necessitating remediation strategies like quarantine networks and captive portals. Quarantine networks restrict user access to specific hosts and applications through techniques such as VLAN assignment or address management protocols. Captive portals intercept HTTP access, guiding users to update their systems before granting full network access, mirroring the approach seen in paid wireless access points at public locations. In mobile NAC deployments where users connect over various wireless networks, challenges arise due to differing connection speeds impacting automated remediation processes. A mobile NAC solution provides administrators with control over when and how security concerns are addressed, allowing for customized approaches based on the severity of the issue, network connection type, and productivity needs. This flexibility enables a balance between maintaining security measures and ensuring uninterrupted workflow for employees.